The conception of the Lockheed P-38 Lightning began in 1937 when the United States Army Air Corps issued a demanding requirement for a high-speed, high-altitude interceptor capable of climbing rapidly, carrying heavy armament, and maintaining superior range. This specification, designated as Circular Proposal X608, aimed to produce an aircraft fast enough to counter the growing threat posed by modern European fighters and bombers, whose performance had rapidly advanced by the late 1930s. Lockheed, under the leadership of Hall Hibbard and the young but exceptionally skilled engineer Clarence Kelly Johnson, devised a radical solution that broke from conventional single-engine fighter designs of the era. Johnson's team proposed a twin-boom configuration powered by two Allison V1710 liquid-cooled engines, each driving a counter-rotating propeller to eliminate torque issues. The central nacelle would house the pilot, armament, and nose landing gear, while the twin booms carried the engines, radiators, and tail surfaces connected by a horizontal stabilizer. This layout promised not only high speed and climb performance, but also concentrated firepower, with all weapons mounted in the nose for exceptional accuracy, avoiding the need for convergence adjustments typical of wing-mounted armaments. The Lightning's innovative design also introduced several advanced features aimed at meeting the Air Corps' ambitious specifications. Its tricycle landing gear, uncommon at the time, improved ground handling and pilot visibility during takeoff and landing. The use of turbo superchargers on the engines allowed the P-38 to maintain power at high altitudes, granting it superior climb rates and operational ceilings compared to most contemporary fighters. However, these innovations came with significant engineering challenges, balancing the twin-boom airframe for stability, integrating the cooling systems without creating excessive drag, and ensuring reliable turbo supercharger operation all required extensive development and testing. Additionally, the aircraft's size and complexity made it far more expensive than typical single-engine fighters, raising concerns about its practicality for mass production. Despite these obstacles, the design's potential led to Lockheed receiving the contract to build the prototype, designated XP-38, setting the stage for the creation of what would become one of the most distinctive and versatile fighters of the Second World War. The prototype XP-38 first took to the skies on January 27, 1939, marking a dramatic departure from the fighters of its day. The aircraft immediately demonstrated remarkable performance, achieving speeds of 413 miles per hour during test flights, making it one of the fastest military aircraft in existence at the time. Its climb rate and handling characteristics impressed Army Air Corps officials, validating many of Lockheed's design choices. However, the program faced early setbacks, most notably when the prototype crashed during a transcontinental record attempt in February 1939 due to carburetor icing, a problem that highlighted the vulnerabilities of the new power plant and turbo supercharger systems. Subsequent prototypes and pre-production models addressed these issues through improved carburetor heating systems, redesigned radiators, and enhanced engine controls. Lockheed also refined the control surfaces and strengthened the airframe to better handle compressibility effects encountered during high-speed dives, which had caused dangerous control stiffening during early testing. The transition from prototype to operational aircraft involved significant modifications to make the P-38 combat-ready. The production versions incorporated more robust armament, typically including 4 50-caliber machine guns and a 20mm Hispano cannon in the nose, giving the Lightning devastating firepower with unmatched accuracy. The turbo supercharger installations were improved for reliability, while the cockpit was equipped with better instrumentation and heating systems to address the extreme cold pilots faced at the high altitudes the aircraft could reach. Despite its complexity and cost, the P-38 entered production in 1940, with Lockheed scaling up its facilities to meet growing military demand as global tensions escalated into full-scale war. Its combination of speed, firepower, and range positioned it as a uniquely capable aircraft, one that would soon prove invaluable in roles far beyond its original interceptor designation. The P-38 entered operational service in early 1942, initially with squadrons deployed to the European and Pacific theaters. Its first combat operations were primarily in reconnaissance and escort roles, where its long range and high speed allowed it to cover missions beyond the reach of other Allied fighters. In Europe, the Lightning's debut was challenging. Pilots struggled with engine reliability in cold conditions and had to adjust to its distinctive handling, particularly at high speeds where compressibility could lead to loss of control if not managed carefully. However, in the vast expanses of the Pacific, the P-38 quickly demonstrated its value. Its twin engines offered both speed and redundancy over long stretches of ocean, making it far safer than single-engine fighters for long-range patrols and escort duties. Pilots praised its heavy armament and stability as a gun platform, which allowed it to excel in boom and zoom tactics against more maneuverable but lightly built Japanese aircraft. The Lightning's combat effectiveness grew as tactics adapted to its strengths. In the Pacific, it became the aircraft of choice for long-range interception and offensive sweeps, famously serving as the mount for aces such as Richard Bong and Thomas Maguire, the highest-scoring American fighter pilots of the war. Its speed and range made it instrumental in missions like the interception and downing of Admiral Isoroku Yamamoto's aircraft in April 1943, a precision operation deep in enemy territory. In the European theater, P-38s were increasingly used as bomber escorts, though they faced stiff opposition from German fighters and challenges related to their performance in colder, high-altitude conditions. Continuous refinements, including improved cockpit heating and engine reliability, allowed the aircraft to remain a key asset despite these difficulties, particularly in roles such as photo reconnaissance, where its speed and range made it unmatched. Over the course of the war, the P-38 evolved through numerous variants to address operational feedback and expand its mission set. The early P-38F and G models were progressively upgraded into later variants such as the P-38J and L, which featured more powerful engines, enhanced cooling systems, and strengthened airframes to handle the stresses of high-speed dives and extended missions. Drop tanks were introduced to further extend range, allowing the Lightning to escort bombers deep into enemy territory. Specialized versions included the F-4 and F-5 photo reconnaissance models, which removed armament to save weight and carried advanced cameras for strategic intelligence gathering. These unarmed variants proved invaluable for mapping and scouting in both European and Pacific theaters, where they often flew deep over hostile territory, relying solely on speed and altitude for protection. Night fighter adaptations, though limited in number, experimented with radar installations, while others were equipped as fighter bombers carrying bombs and rockets for ground attack missions. By the end of World War II, the P-38 had earned a reputation as one of the most versatile and distinctive fighters of the conflict, with over 10,000 units produced. While it was gradually phased out of frontline service after the war, replaced by faster, more advanced piston engine fighters and the emerging generation of jets, its influence endured. Many surviving airframes were transferred to Allied nations or used in secondary roles, while others became museum exhibits or were preserved by private collectors. The Lightning's innovative design, its twin boom layout, concentrated nose-mounted armament, and use of turbo superchargers left a lasting imprint on aircraft development, showcasing how unconventional solutions could meet and exceed demanding performance requirements. Today, restored P-38s fly at air shows worldwide, serving as reminders of an aircraft that combined speed, range, and firepower in a way that helped define Allied air power during World War II. The prototype XP-38 marked a technological leap for the United States Army Air Corps when it first flew on January 27, 1939, delivering a glimpse of performance far beyond that of existing fighters. Its speed, recorded at over 400 miles per hour during tests, placed it among the fastest military aircraft of the era. The innovative twin-boom configuration, tricycle landing gear, and turbo-supercharged Allison engines set it apart from all contemporary designs, but these same elements also introduced numerous technical challenges that required extensive refinement before it could become a combat-ready platform. Early trials revealed reliability issues with the turbo-superchargers, which suffered from overheating and mechanical failures when operating at high altitudes. The complex cooling system for the engines, integrated into the booms and radiators, demanded repeated redesigns to balance aerodynamic efficiency with sufficient thermal regulation. Additionally, pilots noted that the aircraft's unusual control characteristics, particularly during steep, high-speed dives, resulted in dangerous compressibility effects, where shock waves formed around the airframe, stiffening controls and locking the aircraft into a dive unless corrective measures were taken. A major setback occurred in February 1939 when the prototype crashed during a record-setting transcontinental flight attempt due to carburetor icing, which caused both engines to lose power near the end of the journey. While the aircraft was destroyed, the incident yielded critical lessons for the development team, prompting improved carburetor heating systems, revised intake designs, and refinements to the engine controls to enhance reliability in varied atmospheric conditions. Subsequent YP-38 pre-production models incorporated these fixes, as well as strengthened control surfaces and aerodynamic tweaks to mitigate compressibility problems. Engineers also worked to optimize the balance between structural strength and weight, ensuring the Lightning could withstand the rigors of combat while preserving its high-speed capabilities. As testing progressed through 1940 and 1941, Lockheed scaled its production capabilities to accommodate anticipated demand, even as adjustments to the design continued. Turbo supercharger reliability improved, and flight tests confirmed that the P-38 could sustain exceptional climb rates and reach altitudes exceeding 35,000 feet, performance levels few fighters of the period could match. Its nose-mounted armament of 4 50-caliber machine guns and a 20mm cannon was finalized, offering unmatched accuracy and concentrated firepower without the convergence issues that plagued wing-mounted weapons. Although the aircraft's size and complexity remained points of debate, the combination of raw speed, range, and firepower made it clear that the Lightning could fill roles beyond its initial interceptor designation. By late 1941, as the United States edged closer to direct involvement in the global conflict, the P-38 had advanced from a revolutionary prototype into a production fighter ready to meet the demands of a rapidly changing air war. The P-38 Lightning began entering operational service in early 1942, with its first units assigned to squadrons in both the European and Pacific theaters. Its arrival marked a significant shift in American air power, as it provided the Army Air Forces with a fighter that could outclimb, outrun, and outgun most contemporary adversaries while flying missions well beyond the range of single-engine aircraft. The aircraft's exceptional range quickly made it the preferred choice for patrol and escort duties, particularly in theaters where long distances separated bases from combat zones. Its twin engines offered a margin of safety over vast oceanic expanses, which made it especially valuable in the Pacific, where pilots could rely on the Lightning's redundancy if one engine failed during transit or combat. Early missions included long-range reconnaissance, bomber escort, and interception patrols, roles where its speed and heavy armament gave American forces a decisive advantage during the war's opening stages. However, the Lightning's introduction was not without challenges, particularly in Europe. Pilots quickly discovered that the aircraft's turbo-supercharged engines and cooling systems were sensitive to cold weather, leading to mechanical failures and performance issues at high altitudes over the continent. Compressibility effects in steep dives remained a hazard for inexperienced pilots, as control stiffening near transonic speeds could lead to dangerous loss of control if proper recovery techniques were not applied. These difficulties required both technical solutions and extensive pilot training, with modifications to cockpit heating, engine controls, and operating procedures gradually improving reliability. Despite these setbacks, the P-38 still found critical roles in the European theater, where its speed and altitude advantage allowed it to conduct vital photo reconnaissance and to escort bombers deeper into Axis-controlled territory than any other Allied fighter could manage at the time. In the Pacific, the Lightning's strengths were immediately apparent, and it quickly became a cornerstone of Allied air strategy. The vast distances of the theater played to its advantage, as its long range and twin-engine reliability allowed missions that were beyond the capabilities of aircraft like the P-40 or early P-51 variants. Its concentrated nose-mounted armament, 4 50-caliber machine guns, and a 20mm cannon proved devastating in combat, delivering lethal bursts without the need for complex convergence adjustments. Pilots flying the Lightning adopted boom and zoom tactics, using its speed and climb to dictate engagements against the more agile but lightly built Japanese Zero and Kai-43 fighters. Its rugged construction also enabled it to absorb battle damage and return safely from missions that would have downed lighter fighters, a factor that built strong confidence among its crews. Reactions from pilots and commanders reflected a growing appreciation for the P-38's versatility. While its size and handling quirks required a learning curve, many airmen valued its stability as a gun platform, its heavy firepower, and its ability to perform a range of missions without significant modification. Commanders recognized that, unlike other fighters, the Lightning could seamlessly transition between roles, serving as an escort, interceptor, or reconnaissance platform as the situation required. By late 1942, as combat operations intensified, the P-38 had secured its place as a critical asset in multiple theaters, overcoming its early teething problems to become one of the most valuable and distinctive aircraft in the Allied inventory. As the Second World War intensified, the P-38 Lightning's combat role expanded far beyond its original concept as a high-speed interceptor, evolving into one of the most versatile aircraft in Allied service. In the Pacific theater, it became the backbone of long-range fighter operations, excelling in air superiority, bomber escort, and ground attack missions. Its long range, often extended further with drop tanks, allowed Lightning squadrons to escort heavy bombers on deep strikes against Japanese-held islands and supply lines, offering a protective presence over distances where single-engine fighters could not operate effectively. Its concentrated nose-mounted firepower made it particularly lethal in air-to-air engagements, while its ability to carry bombs and rockets turned it into a formidable strike platform for attacks on shipping, airfields, and ground installations. Pilots relied on its superior speed and climb to execute boom and zoom tactics, diving on enemy formations before climbing back to safety, a method that capitalized on its strengths while minimizing the risks posed by the highly maneuverable but lightly armored Japanese aircraft. One of the most notable operations involving the P-38 occurred in April 1943 when a squadron of Lightnings intercepted and shot down the transport carrying Admiral Isoroku Yamamoto, the architect of the Pearl Harbor attack. The mission, flown over 400 miles from Guadalcanal and deep into enemy territory, demonstrated the Lightning's unmatched range and precision in executing long-range interception missions. Such feats cemented its reputation as a strategic asset in the Pacific, where it became the preferred aircraft for America's top aces, including Richard Bong and Thomas Maguire, who scored the highest aerial victory counts of any U.S. pilots during the war while flying P-38s. Its ability to endure extensive damage and still return safely to base further bolstered the confidence of its crews, who trusted the aircraft not only to deliver results but also to bring them home from missions over vast ocean expanses. In Europe, the Lightning's operational use evolved to meet the different demands of the theater. While it initially struggled with engine reliability and cockpit heating in the colder climates, continued refinements allowed it to assume vital roles as a bomber escort and reconnaissance aircraft. Its speed and range enabled it to escort bombers on missions deep into Germany before the arrival of the P-51 Mustang, filling a crucial gap in the early stages of the Allied strategic bombing campaign. Though it faced stiff opposition from well-armed and maneuverable German fighters like the Bf-109 and Fw-190, the P-38's heavy armament and diving ability made it a formidable opponent when used in energy-based tactics rather than dogfighting at low speeds. Its dual engines also offered a survival advantage for pilots who sustained battle damage, as the Lightning could often limp back to base even if one engine was disabled. The aircraft's versatility also extended to specialized missions beyond traditional fighter duties. Many P-38s were adapted for ground attack operations using bombs, rockets, and strafing runs to disrupt enemy logistics and fortifications. Others served as dedicated photo reconnaissance platforms, designated as F4 and F5 models, which removed weaponry to reduce weight and carried high-resolution cameras for mapping and intelligence gathering over enemy territory. These unarmed Lightnings became some of the most valuable assets in the Allied arsenal, often flying deep into hostile airspace at high altitude, relying solely on their speed and altitude to avoid interception. Through constant adaptation and the development of new tactics, the P-38 maintained its relevance across varied combat roles, becoming a true multi-role platform at a time when most fighters were optimized for only one or two specific functions. By the later stages of the war, the Lightning had firmly established itself as a critical tool of Allied air strategy, equally capable of dominating dogfights, escorting bombers, striking ground targets, and gathering intelligence. The P-38 Lightning's development did not stop once it entered widespread combat service. Instead, it underwent continuous refinement and adaptation, resulting in a series of variants that enhanced its performance and broadened its mission profile. Early combat models, such as the P-38E and P-38F, introduced incremental improvements over the original design, addressing issues with engine reliability, control harmonization, and cockpit ergonomics. These versions standardized the armament layout of four 50-caliber Browning machine guns and a 20mm Hispano cannon in the nose, solidifying the Lightning's reputation for accurate, concentrated firepower. However, feedback from frontline squadrons highlighted areas in need of further enhancement, particularly the need for better engine cooling, improved high-speed stability, and greater range for extended missions in the Pacific and European theaters. These operational demands led to major upgrades in later variants such as the P-38J and P-38L, which became the definitive wartime Lightnings. The P-38J introduced redesigned engine nacelles with larger radiators and improved intercoolers, allowing the Allison engines to sustain higher power levels without overheating during long climbs or extended cruise. The P-38L, the most produced version, incorporated strengthened wings, dive recovery flaps to counteract compressibility issues during high-speed dives, and provisions for underwing pylons that could carry bombs, rockets, or additional fuel tanks. These additions transformed the Lightning from a high-speed interceptor into a true multi-role aircraft, equally capable of bomber escort, ground attack, and reconnaissance duties. Despite the added weight from these modifications, its twin engines provided ample power to maintain competitive speed and climb performance, while its turbo superchargers ensured operational capability at altitudes beyond the reach of many enemy fighters. Beyond its primary fighter role, the Lightning spawned specialized versions that expanded its contributions to the Allied war effort. The F-4 and F-5 photo reconnaissance variants became indispensable for strategic intelligence gathering, mapping enemy defenses, and planning major operations. Stripped of armament to save weight, these aircraft relied entirely on their speed and altitude to survive deep penetration missions over Axis-controlled territory. Other adaptations included night fighter conversions equipped with early airborne radar, though these were produced in limited numbers due to the aircraft's size and the rapid development of purpose-built night fighters like the P-61 Black Widow. Some Lightnings were modified for Pathfinder roles, guiding bomber formations with advanced navigation equipment, while others were fitted with rocket launchers and bombs for close air support during campaigns in Europe and the Pacific. Production of the Lightning was a significant industrial undertaking, with over 10,000 aircraft built between 1941 and 1945. Lockheed's assembly lines, supported by subcontractors, scaled dramatically to meet the needs of multiple theaters, and the aircraft's complexity made it one of the most technically demanding fighters of the war to produce and maintain. Yet its unique combination of range, speed, and versatility ensured it remained in demand until the conflict's end. By continuously evolving through successive variants and roles, the P-38 Lightning not only adapted to the rapidly shifting demands of World War II, but also demonstrated how a single, innovative airframe could serve as the foundation for an array of combat and reconnaissance missions, setting a precedent for multi-role fighters in the post-war era. By the end of the Second World War, the P-38 Lightning had secured its place as one of the most distinctive and influential Allied fighters, not only for its combat record, but also for the impact it left on post-war aviation and military doctrine. Though rapidly overshadowed by newer piston-engine aircraft like the late-model P-51 Mustangs, and by the advent of jet fighters, the Lightning's combination of range, firepower, and adaptability had already shaped how designers and commanders viewed multi-role combat aircraft. The nose-mounted armament, which eliminated convergence issues and delivered precise, concentrated firepower, would influence later aircraft layouts, while the extensive use of turbo superchargers to maintain power at high altitudes became a benchmark for high-performance piston fighters. The twin-boom design, unconventional yet effective, also inspired later experimental aircraft and remained a visual hallmark of the Lightning's innovative character. After the war, most P-38s were quickly retired from frontline service, as jet propulsion rendered even the fastest piston fighters obsolete in air-to-air combat. However, the Lightning did not disappear entirely. Many were repurposed for secondary roles such as training, target towing, and aerial photography. Surplus aircraft were sold or transferred to foreign air forces, with some continuing to operate into the early post-war years, particularly in Latin America, where their durability and heavy armament made them useful even as frontline types faded. Others were dismantled or scrapped as part of the general downsizing of military inventories in the late 1940s, but enough survived in storage or private hands to allow a portion of the fleet to endure. The P-38's legacy is perhaps most visible in its contribution to Allied air superiority and the careers of the pilots who flew it. In the Pacific Theater alone, the Lightning accounted for more aerial victories than any other U.S. Army Air Forces fighter, and it was the aircraft of choice for America's two highest-scoring aces, Richard Bong and Thomas Maguire. Its long range and survivability allowed these and many other pilots to conduct missions deep into enemy territory, an operational flexibility that became a model for post-war long-range fighter concepts. Reconnaissance variants, particularly the unarmed F-5 models, provided intelligence that was vital to the planning of Allied offensives, demonstrating the importance of high-speed, high-altitude scouting platforms, a role that would later be assumed by jet-powered aircraft like the U-2. Today, the P-38 Lightning endures as both a technological milestone and a celebrated piece of aviation history. Several restored examples remain airworthy, appearing at air shows where their distinctive twin-boom silhouette and unique engine note continue to capture public attention. Many others are preserved in museums across the United States and abroad, often displayed alongside the stories of the pilots and squadrons that made the aircraft legendary. Beyond its physical presence, the Lightning's influence persists in the design philosophies it helped to validate. Centralized firepower, long-range operational capability, and adaptability across multiple mission types, all traits that would be refined and carried forward into the jet age. Although its time as a frontline weapon was brief compared to the rapid technological leaps that followed, the P-38 Lightning remains a testament to the innovation and bold thinking that defined aviation during the Second World War, standing as a symbol of how unconventional design can achieve lasting impact in both combat effectiveness and the evolution of air power. Beyond its well-documented combat record, the P-38 Lightning had chapters of service and experimentation that are often overlooked, yet they reflect the aircraft's adaptability and its role as a platform for innovation during and after World War II. Several P-38s were converted for specialized research roles, serving as flying testbeds for technologies that would influence post-war aviation. Some airframes were used to evaluate early radar systems and electronic warfare equipment, leveraging the Lightning's spacious nose section and stable flight characteristics to accommodate bulky experimental gear. Others tested aerodynamic modifications, including different wing profiles and control surface designs to study solutions for compressibility effects and high-speed stability, data that contributed to the understanding of transonic flight as the jet age emerged. A few P-38s were even employed in high-altitude experiments, gathering data on pilot physiology and aircraft systems performance in near-stratospheric conditions, foreshadowing studies that would later become standard in jet and space programs. In operational theaters, there were missions that pushed the Lightning beyond its typical combat assignments. Reconnaissance variants, particularly the unarmed F-5 series, flew deep into enemy airspace without escort, photographing industrial sites, troop concentrations, and transportation networks at ranges no other Allied aircraft could reach. These flights, conducted at great risk and without defensive armament, relied entirely on the P-38's speed, altitude, and range for survival. And they delivered intelligence that shaped key campaigns, including the Normandy invasion and the island-hopping strategy in the Pacific. Some Lightnings were adapted for clandestine transport and liaison duties, moving critical personnel or small cargo loads in theaters where their speed and ability to operate from rough airstrips proved invaluable. There were even limited efforts to explore the Lightning's suitability as a fast, long-range mail and courier aircraft for post-war military logistics, though such roles were short-lived as newer designs became available. Veteran accounts also shed light on the aircraft's reputation as a pilot's machine, despite its quirks. While early models demanded careful handling in dives and complex engine management, experienced pilots often praised the Lightning's forgiving nature in emergencies. The ability to fly and return safely on a single engine was a lifesaver over the vast expanses of the Pacific, and its rugged airframe could absorb battle damage that would have doomed many single-engine fighters. Some post-war reflections noted that while the P-38 was eventually surpassed by more modern designs, it instilled in its pilots a confidence in their aircraft that was rare among high-performance fighters of the period. Though most Lightnings were retired or scrapped by the late 1940s, a handful continued to serve in civilian capacities. Some were purchased by private operators for aerial surveying, mapping, and even air racing, where their speed and range offered competitive advantages despite rising maintenance costs. Others became static displays, slowly restored over decades by museums and private collectors, ensuring their preservation for future generations. These lesser-known roles, combined with its experimental contributions and the insights of the pilots who flew it, underscore the P-38's enduring significance beyond its wartime fame. It was not merely a fighter, but a bridge between the conventional designs of the interwar period and the technological innovations that defined mid-20th century aviation, leaving behind a legacy that extended into both the scientific and cultural realms of flight history. The legacy of the P-38 Lightning extends far beyond its wartime victories, shaping aviation development and cultural memory in ways that continue to resonate decades after its retirement. Technologically, the aircraft demonstrated how innovative thinking could produce a fighter that excelled in roles traditionally divided among multiple platforms. Its centralized nose-mounted armament, offering unparalleled accuracy and destructive power without the complications of convergence, became a reference point for later aircraft designers. The use of turbo superchargers to sustain engine performance at high altitudes set a precedent for piston engine fighters, and the twin-boom configuration, though unconventional, proved aerodynamically viable and highly adaptable. These features, combined with its ability to operate effectively as a fighter, bomber escort, ground attack aircraft, and reconnaissance platform, marked the Lightning as a prototype of the true multi-role combat aircraft, a concept that would later become standard in military aviation doctrine. Culturally, the P-38 earned an enduring reputation as one of the icons of the Second World War, particularly in the Pacific, where its long range and heavy firepower allowed it to dominate vast theaters of operation. It became the mount of America's highest-scoring aces, Richard Bong and Thomas Maguire, whose successes underscored the aircraft's lethality when paired with skilled pilots. The Yamamoto interception of April 1943, executed by a squadron of P-38s flying one of the longest fighter missions of the war, became emblematic of its strategic reach and precision. These exploits, along with its distinctive silhouette and twin-engine roar, cemented the Lightning's image as a symbol of American air power during a conflict defined by rapid technological and tactical evolution. Post-war, while the Lightning quickly faded from active military use as jet propulsion rendered even the most advanced piston fighters obsolete, its influence persisted in unexpected ways. Surplus P-38s found niche roles in civilian aviation, from aerial surveying and mapping to air racing, where their speed and endurance continued to offer advantages. Some were adapted for experimental research, contributing data to early studies of high-speed aerodynamics and transonic flight, knowledge that would aid in the development of jet and rocket-powered aircraft. Others were preserved by museums and collectors, ensuring that the P-38's unique design and operational legacy remained visible to future generations. Today, restored Lightnings continue to fly at air shows, captivating audiences with the same distinctive profile and sound that once patrolled skies over Europe and the Pacific. These surviving examples not only serve as tributes to the crews who flew and maintained them, but also as reminders of a period when aviation was evolving at unprecedented speed. The P-38's enduring presence in museums, literature, and popular culture underscores its dual identity as both a combat legend and a symbol of innovation. It remains a testament to how unconventional solutions, when executed with precision and purpose, can achieve lasting impact, bridging the gap between the piston-driven fighters of World War II and the jet-powered aircraft that would follow, while continuing to inspire fascination among historians, engineers, and enthusiasts alike. The P-38 Lightning story also reflects a broader shift in how air forces approach design priorities and strategic planning, demonstrating that performance alone was not the sole measure of a fighter's value. Its unprecedented range and flexibility proved that a combat aircraft could be more than a specialized tool. It could serve multiple missions across vast theaters, reducing logistical burdens and enhancing operational reach. These qualities inform post-war thinking about the necessity of multi-role aircraft, leading designers to emphasize platforms that could carry out diverse tasks rather than limiting fighters to pure interception or air superiority roles. The Lightning's ability to transition seamlessly between escort, interception, ground attack, and reconnaissance roles became a model for future fighters, paving the way for aircraft like the F-4 Phantom II and later multi-role designs that would dominate Cold War doctrine. The operational lessons learned with the P-38 also shaped advancements in pilot training and tactical doctrine. Its demanding handling characteristics, particularly during high-speed dives and complex engine management scenarios, required a higher level of skill than many single-engine fighters, compelling the Army Air Forces to refine pilot instruction programs. These training innovations carried forward into the jet age, where aircraft demanded similar precision and energy management to exploit their capabilities fully. The Lightning's long-range escort missions, especially in the Pacific, demonstrated the importance of fighter endurance in achieving strategic objectives, influencing the development of aerial refueling concepts and the prioritization of range in early jet fighter designs. While its combat service concluded with the end of World War II, the P-38 maintained a cultural and technological presence well beyond its retirement. Many surplus aircraft entered civilian hands where they were used for aerial survey work, bush flying, or adapted for air racing, capitalizing on their speed and range. Others were studied by engineers for insights into aerodynamics and high-altitude operations, particularly their behavior near transonic speeds, contributing indirectly to the understanding needed for supersonic aircraft development. Though not a direct precursor to any single post-war fighter, the lessons from its twin-engine layout, turbo supercharger integration, and aerodynamic challenges inform broader research and development efforts during the transitional years from propeller-driven to jet-powered combat aircraft. Today, the Lightning's significance endures not only in its surviving examples, meticulously restored and flown or displayed in museums worldwide, but also in its symbolic role as a bridge between eras. Its design encapsulated both the height of piston engine ingenuity and the lessons necessary to enter the jet age. The P-38's legacy, therefore, is not confined to its wartime accomplishments. It represents the mindset of adaptation and innovation that defined aviation during the mid-20th century. In demonstrating how a fighter could merge range, firepower, and versatility into a single platform, the Lightning helped set the stage for the multi-role fighters that would dominate military aviation for decades, ensuring its place not only as a combat legend, but as a critical influence on the evolution of aerial warfare. The closing chapter of the P-38 Lightning's history reflects both the brevity of its frontline career and the depth of its lasting influence on aviation. By the late 1940s, the rapid rise of jet propulsion had rendered even the most advanced piston fighters obsolete for air superiority missions, and the Lightning, despite its speed and versatility, was no exception. Most surviving examples were quickly retired or sold as surplus, with many scrapped for parts or repurposed for civilian applications such as aerial surveying, cargo hauling, or air racing. Yet even as it disappeared from active rosters, the aircraft's legacy was already secured by its achievements during World War II, where it had served as a crucial asset in multiple roles: fighter, bomber escort, reconnaissance platform, and strike aircraft, often accomplishing missions no other Allied fighter could match. The Lightning's design innovations remained influential long after its retirement. Its nose-mounted armament configuration became a point of reference for later fighters and attack aircraft, showing the advantages of centralized firepower for accuracy and destructive efficiency. Its twin-engine layout, combined with turbo superchargers for high-altitude performance, validated design principles that informed not only other late-war aircraft but also experimental research as engineers transitioned toward jets. Lessons learned from its high-speed dive characteristics and compressibility issues contributed to the understanding of aerodynamics near transonic speeds, laying groundwork for the testing and development of supersonic aircraft in the 1950s and 1960s. Culturally, the Lightning's status as one of the most distinctive and successful American fighters of the war has kept it firmly embedded in public memory. Its striking twin-boom silhouette, unmatched among frontline fighters of its era, and its association with the highest-scoring American aces ensured it became an enduring symbol of U.S. air power in the Second World War. The Yamamoto interception, long-range sweeps over the Pacific, and deep reconnaissance missions over Europe all became hallmarks of the aircraft's legacy, frequently retold in histories, documentaries, and aviation literature. This cultural prominence ensured a sustained interest in preserving the P-38, with aviation museums and private collectors dedicating significant effort to restoring surviving airframes to flying condition. Today, the P-38 endures not only as a centerpiece at air shows and in museum collections, but also as a reminder of a critical turning point in aerial warfare, when technology, tactics, and strategic demands converged to produce aircraft that could serve multiple roles with equal effectiveness. It represents the pinnacle of pre-jet fighter design, bridging the gap between the specialized single-engine fighters of the early war years and the versatile, high-performance aircraft that would dominate the skies in the decades to follow. Though it no longer flies in combat, its preserved examples and the design philosophies it championed ensure that the Lightning's influence continues, both as a celebrated artifact of World War II and as a testament to the bold engineering choices that shaped the trajectory of modern military aviation.